We're now going to answer this past VCAA question. It is taken from VCAA 2019, paper 1, question 6. It says, a water park is open from 9 a.m. until 5 p.m. There are 3 activities: the pool, the slide, the water jets at the water park. Children have been found to change their activity at the water park each half hour, as shown in the transition matrix T below. So if we look here, if we've got a kid using the slide, 20% of those will then use the pool in the next half hour. So too, if they're using the water jet, then 10% of those are going to use the slide in the next half hour. Perfect. Let's now read the rest of the question. It says, a group of children has come to the water park for the whole day. They've come for the whole day. The percentage of these children who are expected to be at the slide S at closing time is closest to which of these? Okay, the first thing that we have to take note of here, and you need to make sure that you underline or highlight it, is the word percentage. And that brings us back to this dot point right here, which says when we're simply looking at percentages, we can raise the transition matrix T to a high power, and it should reach some consistency across time. So we don't have to use this definition of the steady state here, in which we have to know the initial conditions. We don't need to know the initial state here. Rather, we can just take our transition matrix and raise it to a very high power to get the steady state here. Now, what makes this question so interesting is that it actually doesn't mention that it's after the steady state, but kind of implicit in it is you understanding and recognizing that the only way for you to answer this is for you to know, oh, I'm after the steady state here. They've been here for the whole day. So it's been a long time. Now I just need to raise it to like a reasonable number within that whole day in order to get that transition state, that steady state. I do not need the initial state here to get the answer. Now we can actually figure out, how many half hours they've been here for, because if they've been here for the whole day, and I know that it opens at 9 a.m. and closes at 5 p.m. So it's 9 a.m. until 5 p.m. Well, that means that, how many hours is that? That's 8 hours, right? Therefore, it's going to be 16 half hours. So that means what I have to do is take my transition matrix T and raise it to 16. And let's see what happens when I do that. So notice, because I'm after percentage, I do not need to know the initial state here. This will work. I don't have to use this formal definition here. I'm just using this, T raised to 16. So I've already typed in my transition matrix here. Then I'm going to raise it to the power of 16. And I'm going to get this matrix right here. Now, let's just write it down and really take note of what it's saying to us. All right, so as you can see in my first row here, I've got 0.62, 0.62, 0.62, 0.62 again and again and again. So let's just write those down. I've got 0.62, 0.62, 0.62. Then in my next one, what do I have? I have, and I'm going to round this, I have 0.137, 0.138, 0.137. So if I was to round that, I'm getting 0.14, 0.14, 0.14. And then we come to the next one, the next row here, I've got 0.24, 0.24, 0.24. So here I've got 0.24, 0.24, 0.24. Okay, now remember, this has given us what they're using, the P, S, and W in the next half hour here. So hopefully you can see what's happening to the water slide here. The water slide. It's going to end up being 14. And that's exactly what this line here tells us, that, when you're after percentages, we can just raise the transition matrix T to a high power, and it should reach some consistency across the values. And as you can see, that's what's happened here. That means my answer is A. It is 14%. Okay, let's now read the examiner's report, because this question actually wasn't well done. So let's come over here and let's read this. So as you can see, 39% of people got this question correct. The answer was A, as we wrote down. Now, when a question isn't answered well, VCAA gives a bit of an explanation as to what's happened and what's kind of gone wrong here. So for question 6, we read the following. Students needed to recognize that this question involved long-term expectation. So in other words, when it's saying long-term expectation there, you needed to recognize that we're after the steady state here. Okay, let's keep reading. It says, although the number of half hours that the group, sorry, let me say that again. Although the number of half hours that the group stays is not defined, it makes little difference whether it's taken to be 10, 15, 20, or higher. Now, this is where I actually disagree a bit. It says the number of half hours the group stays is not defined. Well, it is defined, is it not? Because it says that they stay the whole day and the water park opened 9 a.m. to 5 p.m. So it's clearly 16 half hours there. But they're saying here it actually doesn't matter. You could have put in 10, 15, 20 or higher, and we would have gotten the same result out. So let's just check this. If I had put in 20, well, if it's the steady state, it's definitely going to give me the same thing out. As you can see, it's worked. And as you can see, we've got a bit more consistency across this row here. 13.7, 0.137, 0.137, 0.137, 0.137. When up here, we didn't have that consistency. Do you see how we had 0.138, 0.138 there? So that's interesting. And then what if we actually went down one? What if we went down to 10? They're saying that this would give me the steady state as well. And it did, 0.137, 0.14, 0.1. So it's close, It's quite clear that once I round this to whole numbers, I'm going to get 14 there. It also tells us that there is no... Whoopsie daisy. It also tells us that there's no initial state needed. There is no initial state needed, and that's correct. Because we're after percentages, there's no initial state needed. That's what this dot point here told us. All right, if we continue on. Raising the transition matrix to any of these powers will give the percentage at S to the nearest whole number to be 14%. Perfect. So this question wasn't done well, so hopefully that makes sense. And yeah, I'll see you later.